Okay, so we're going to try to figure out the volume of revolution using different approaches and see which one fits us. Let's see. We have got an example. Let's say we've got an equation which is y equal to x square given to us. So you know it looks like that. And there is an area which is trapped between the curve and x equal to 2 and x equal to 0. So it's basically this area which is trapped. Now they're saying to figure out the volume of revolution for this area if it is rotated about the y-axis. So there are two ways one can approach, and this video is intended for you to see if the vertical strip, if the strip you take needs to be vertical, if it needs to be horizontal. So let's take up the example where we have actually taken the strip as vertical here. So there, I'm going to go divide the entire area into little strips like these here. The thickness of these strips is dx. And of course, the height is equal to the y coordinate of that point. And if you go from the origin, measure this length, it's supposed to be the x coordinate of the point. And since the strip is dx in length, this whole length from this point to that is going to be x plus dx. Now, if you go rotate this strip about the y-axis, you are going to get something like that out there. There. A thin cylinder is what you're going to get. This is what you're going to get if you rotate that strip about the y-axis. Let's try to figure out the volume of this thin strip, this thin cylinder. Well, if I go try to figure out the volume of this thin cylinder, I know it can be the volume of the outer cylinder, which has a radius of x plus dx. There it is, outer cylinder, x plus dx, minus the volume of the inner cylinder. It's a pi times x square y. The formula we're using is pi r square h. Well, h is the height of that strip, it's a y, and r is the radius. The larger cylinder, outer cylinder, has a radius of x plus dx, and the inner cylinder has a radius of x. And that is why the volume generated by that thin strip is this out there. If you go expand the bracket here, if you go expand this bracket, you end up with these terms and the pi x square y as it is. Later, if you open up the bracket, these are the terms you get from the first bracket, and of course pi x square y as it is. And the point is pi x square y here and pi x square y there, they cancel out. This here is a quantity which is very small. Look at a quantity which is as small as dx, let's say 10 to the power of minus 6 meters. Square it, you're going to end up with a 10 to the power of minus 12 meters square. So you know dx when squared is actually a very small quantity. So this, we simply ignore. What you're going to remain with is this thing. And that is why the formula 2 pi x y dx, y can be written as fx. And that is why the formula of 2 pi x fx dx for that little strip. Okay, what would be the volume of the entire area when it rotates? It'll be integral of 2 pi x fx dx. And you see how we've put up a dx out here. The limits are supposed to be for the x values of the strip which is out here, that little place, and for the strip out here. In a way, you cover all the strips, vertical strips possible between these two, the one out here and the one out here. So the limits are supposed to B for x equal to 0 to x equal to 2. There, this whole thing. So that all the strips are covered. And that is why we've put up the limits of 0 to 2 on 2 pi x fx. If you solve this, you're going to end up with a 8 pi. There it is. That's why working for it. So fx is a x square there. And 0 to 2, you end up with a 8 pi. Well, there is another way of approaching the same area now. What we do is we take the strip parallel to the x-axis this time. There it is. And now you see the width of the strip is dy. This entire length is a 2. This length is a x. And that is why this length is 2 minus x. Okay. Now, what is the cylinder that you're going to get out when you rotate this strip? Well, this is something you're going to get. Let's remove those. Something like that is what you're going to get when you rotate that strip. What is the volume going to be? And again, we're going to go do the same thing. There it is. Volume of the outer cylinder, pi into radius of the outer cylinder is a 2 minus the inner cylinder. There it is. That inner shell. This thing. Radius is a x for it. And now you go do a pi x square dy. And you end up with that as the formula. Remember, these time the strips are supposed to go start from here and reach up there. So they're going to go like that. So the y coordinate is going to go from a 0 to a 4. And that is why we put up the limits 0 to a 4 on dy on this function. We've put a limit of 0 to 4. And again, when you solve it, you will end up with the same volume. There it is. Remember, x square is a y. So that is why this becomes a pi y dy to be integrated, and it comes out to be pi y square by 2. This is a 4 pi integrated. It'll become a 4 pi y. And the limits would be from the lowest strips y to the highest strips y. And it's going to be 0 to a 4. That is why 0 to a 4 on comes out to be a 8 pi. So that is your idea. Both the methods actually work, but it depends on the easiness, how easy it is. It was a little twisted if you use this method. This is known as the disk method. And it was very easy if you had done it this way. It was the shell method. So sometimes the shell method is easier to use and the disk method is difficult. This is one example where it was something like that. We'll go do more examples of this kind in the video that comes next.